digital transformation. Everyone talks about the digital revolution, digital this, digital that. Digital runs on data. So really this is about how you enable organizations to capture, enrich, validate, transform, and use data. Similarly with digitization, digitization is really about the tools and the processes that operate that data. That's really all it can be about, because an interface, a web interface, is useless without some data in it. And finally, culture, and it's a very, very, very important part of this, is people, because it's people interacting with systems, people using that data, people cataloging that data, people deriving value from that data. And trying to combine all three is not easy, as we all know. That's why change often fails in organizations. And from our perspective, if I come back to that slide early on, I talked about our agile transformation process. It actually is all about the people, because you need to talk to the people, the users, the stakeholders, to understand what they need, what they want. You then go off and build some tooling. You go off and build some architectures that enrich that data and surface it, but you've then got to validate it and say, well, is that what you wanted? Is it producing the outcomes you expected? They're the arbiters of quality, arguably. So combining all three of those is the magic here. And the point about digitization, why do we do it? Well, if it's done well, it reduces cost by reducing friction. It improves usability and visibility for people. But more importantly, I think it frees up human talent to tackle high value problems. So this idea that we're all going to be redundant in 5 years because of AI has never struck me as being a very likely truth. All it does is it says, well, if you're not doing it and your competitor is, they're going to have a cost advantage or a speed advantage. So get on the bandwagon. But they'll still have people then trying to derive the next layer of value, the next layer of innovation. So machines are only so good. Humans are the ones that innovate. And then hopefully we commoditize that into a machine. That's really what we're talking about here. And if we do it right, it helps to accelerate the speed of development across an enterprise in many, many, many different ways. So we'll go into some of those. And continuing the aquatic theme here, let's talk about the oceans of data that exist in many organizations. So the need to match architecture to the business requirements. There is I believe, a maxim in systems design that talks about the architecture that an organization ends up with around its data and its systems often reflects its culture, kind of not surprisingly. And you literally see organizations that are very open and collaborative and sharing, as are their systems and their data. And those organizations that are verging on the paranoid and are very much, should we say, secretive or competitive within functions, you often see very deep silos of data. Not surprisingly, because the people in there are driven by culture, and the culture determines the choices they make, the systems they build. So just to sort of tick some boxes, we talk about operational databases and data stores. So that could be a place where you literally have a lot of operational data. You've heard about data warehouses, and they can come in different forms. So data warehouses are notionally a place where you warehouse data. Has some pros, has some cons. Some, pros are you can put it all into one place, a bit like Amazon. But on the other hand, you're chucking in data from sources without normally validating it, without knowing the data that's in there. It's only when it's in the store do you try and find it, and most of the data doesn't have a barcode on it, so it's kind of hard to find it. And then you end up with these data lakes. It is sort of variation perhaps of the theme. We're still a data swamp, so it really is a mungy form of data, very hard to derive value from. And then there are some specific architectures, the Lambda, Kappa, and one that's become quite recently adopted is called data mesh, that if we get time we can go into. A data mesh is really a solution to the problem where you have a large organization with many, many golden source systems. So I mentioned one of the banks earlier on. They had one client of ours has 240 different enterprise systems which do fund accounting, and they've got 3 different fund accounting systems. They're different vendor systems, different architectures, different data schemas. And that's partly historic because one of them serviced Asia, one serviced the US, and one serviced European clients. That's fine until one of their clients in Asia says, I will now want you to service me in Europe. So all of a sudden, they're servicing that same client with notionally the same service line, product line, but 3 different data stores, 3 different schemas, 3 different, how do you pull that together and give them a single view of the truth? And that's just one bit of what they do for them. They also do TA, they do custodian and sub-custodial systems. So before you know it, there are 30, 40 systems that are servicing that one client globally. And you can either copy all that data from those systems that are live running systems, chuck it into a warehouse and then hope you derive value from it, or you can use a data mesh type architecture, which we'll touch on later on. The other point about data domains, so not all data is equal, not all data is equally valuable. So we choose to make some distinctions. And in our area, we choose to make some distinctions around market data versus operational data versus networks and relationships. So let me give you a little bit of a sort of distinction. Market data, you know, as the name suggests, is really about what's out there to some degree. So it could be pricing data. Bloomberg is a source of market data, as was Reuters years ago. And there are many, many, many sources of market data. Some are very well curated, very accurate, and some are not. Some are alternative market data sources. So you might look in the renewable space. You are looking for things like weather forecasts that enable you to get some idea of how fast the wind's going to blow in a given area, like a hill where you've got a wind farm or a solar farm, and you're trying to use that to predict the production of energy in the next half hour. So it's an alternative data source because A, it's not particularly accurate. B, you might have millions of them because you've got many, many different areas, micro wind forecasts. C, you might enrich that with other data sources like radar, for example. If you did the same for someone like Cargill, a very big agricultural commodities business, they're trying to map the world. They map rainfall, they map sunshine, they map all sorts of floods, they map all sorts of environmental factors. And so, okay, from this, we're going to try and predict crop growth in a given area. And from that, we'll predict, therefore, yield and finally prices, and then we can ship them to different parts of the world. That's all to do with market data. On the middle bit, you've got operational data. So in a trading world, operational data might encompass your trade, transaction, best execution reporting for MiFID II, so all the post-trade world. And there you're really into fidelity because you really care what you give to the regulator. If it isn't accurate and they come back and ask you questions, you get into hot water. So they're the process of ingestion of that data, the validation and enrichment of it. So you get a very high quality of data before you enrich it. And then you do your analysis and your reporting. That becomes vital. So data fidelity is vital in the operational space. And the final area we've chosen to make a distinction on is around networks and relationships. So if you're in oil trading, an example would be you want to know who you're trading with, who your counterparties are before you book the trade, because many are now subject to sanctions. And it's not easy to say Bob is sanctioned and Jane isn't, because the person you speak to, the person you might be doing the trade with, might be a front for an organization that is sanctioned. So knowing who they are and trying to build those networks is vital. Similarly, in the investment management world, this example we've given here is the global transaction look-through. The European model for fund production at a GAM or a Schroders is basically fire and forget. So I manufacture a fund product, I wrap some regulatory stuff around it, some fund fact sheets, and I fire it down a distribution channel through these platforms. And I don't know who sells them, I don't know who buys them, I don't really care, or didn't care anyway, as long as it's not my problem. Well, unfortunately, MiFID II's put an end to that, so it is your problem anyway. And trying to understand where you're spending your dollars for marketing and sales versus where you're getting the return. You know, are you spending 10% of your money in this arcane, this niche Italian marketplace and getting absolutely no uptake for it? Or are you spending it wisely? Well, right now, many organizations don't know. This network infrastructure we put together allows you to begin to make sense of that and stitch together those distribution paths. So they're three data domains. They require very different architectures, actually quite different technologies in some parts, in order to create a coherent, usable single view of the truth across each of those domains. And the last one is really talking about data maturity here. If Raj is on the call, I'll hand over to him, but if he's not, I shall do it myself.
Hi, Ian, I'm here.
Hello, Raj.
Here
How
from
are
the
you?
very beginning. We talk about backgrounds. So,
fantastic. I shall leave Raj to talk because, frankly, he knows a lot more about this than I am. Welcome, Raj. Raj is our CTO. He knows about all things data. Over to you, Raj.
Fair enough. So, afternoon, folks. And effectively, what we've got here is a data maturity model going from like a pyramid, going from level 1 to level 5. And it talks about the level of maturity for any given organization. And so right at the top of the curve, you can see data-driven organizations. We've heard data-driven quite a few times. What does it mean exactly? Well, it actually means that you've got strategic data. Every single organizational decision is backed up by data. It's something that's kind of forecasting. That's really what it means. But it doesn't start off on that end of the curve. It starts off on the other side. It starts off with no data. Generally, you don't have any data at all to make any educated decisions. Not many organizations find themselves in that. The next level is big data. So that's kind of curious. Going from no to the next level is big data, which just shows the fact that as soon as you have data, you're already in that land of big data. Ooh, the screen's running around a little bit there. Oh, great, it's back again. So you go from the first one, which is regressive, to the second one, which is repeatable. So effectively, you've got behaviors, you've got actions, you've got activities which are repeatable. But you're inundated with data. You have a lot. There's not much structure behind there. So it should be no surprise that the next level is quality data. So you now have sets of data just standardized. In addition, you may adorn the data. You may, if you've ever spoken about this before, we speak a little bit about metadata. You have decorations around data. So you have data describing data. Now, that's a hell of a lot of data. But that's not only a technological problem. There is also a process piece here as well as a people side. So one of the things you'll notice there, it says there's a cultural shift around the organizational behavior. There's no point having a really tidy house if you're going to mess it up all over again. So the housekeeping behind this, the process, making sure that there is known defined roles and responsibilities around that. The next step behind this, once you've got structured data sets, is the predictive side. So looking at these data sets, looking at the past and using it to get some element of understanding around the future. Now, some data-driven decisions will happen, but not all of them. And that's what takes you to level 5, which is effectively any key organizational decision is backed up by good data. Now, if that sounds like a million miles away, don't worry. Level 5s are usually the bastion of large tech companies like Netflix, Facebook, Google, and you generally don't find many enterprise organizations doing that. Generally, you find them at probably the level 3 or level 2 sometimes. And that's what we do. We take certain organizations maybe at level 2, bring them to level 3, or level 3, bring them to level 4. And that's generally the fatter middle. That's a little bit about data maturity.
Thank you, Raj. Do you want to talk about data silos as well whilst you're here?
Oh, why not?
Rather you than me.
So you probably heard the term data silo. In fact, it was a few days ago that I was in a client meeting, and I said they were talking about putting in a brand new system, and one of the caveats there was just make sure that you don't go through a very large 3-year process where you're replacing one data silo for another, because you do see those peaks and curves where you get an entire platform, you go, oh, there's a series of problems around this, we'll bring in a new solution. It's another 3 years, replacing that, and the next thing comes in. Lather, rinse, repeat. But data silos exist for a particular reason, or a number of reasons. Generally, you have a platform where there is a clear purpose. Maybe it's taking in fun data, for example. But then the purpose changes. You go, oh, it's a really good source of data. Perhaps we can just use it for something else, or we can start adding a bit more data to this, or we can start tapping into another system here. And then suddenly you found that you've got more connectivity than was originally envisioned. But chances are the schema behind it, or the model, the structure of that, the data behind the silo was quite tuned to its original purpose. And so now when there's a new purpose or a new need or a new kind of value stream that's required from that data, you can't change it so easily. So it's an inflexible schema. In addition, one of the things you'll find is that, especially around large organizations where you have trading desks or market data desks, there's these areas of connectivity where a desk might say, okay, well, I want this particular weather data that needs to happen here. And they'll just tap in that data source. And all of a sudden, you've got this ungoverned landscape. Suddenly, these pools of data just building up over time, rather than having a strategic data view across the entire landscape, having governance around it, having strict controls, having versioning, having roles and responsibilities, having an awareness of what are data sources, what are the golden copies, what are the golden sources, all those things. So yeah, there's a few reasons for data silos, Ian.
Thanks very much. Any questions on that before we move on to some more technical aspects of things? No? Okay, good. So I'm now going to hand over to Dennis to talk about the platform that we have called DataMax, and he can explain a bit more about what it is and what it isn't. So don't think of it as a thing, but it's a framework for solving the sorts of problems that we're talking about in the data space. Dennis.
Thank you, Ian. Our answer to the data challenges that Ian and Raj outlined so far is DataMax platform. Why is it a platform? It's a platform and not a product, because what we have seen in practice again and again that none two enterprises, especially mature enterprises, are alike. And what they want is something that is tailored to their specific needs. And the difference could be things like target technical stack. Some companies choose to go with Microsoft's Azure cloud, and some choose Amazon or Google stack, as well as there could be different target technical ecosystems, .NET, Java, Python, and so forth. Additionally, there are differences in culture and approach within an organization. Some organizations are quite quant heavy, and they prefer using Python and tools like that to access and analyze data, for example, whereas other organizations, they want, in addition to that, a good support for Excel, which allows, an element of gradual migration, shall we say. So that's on data consumption, and on data ingestion side of things. Some organizations, they prefer to fully own data ingestion within an IT, while others are looking for ways of giving more power to users in terms of adding new data sources closer to on-demand approach. So none two enterprises are the same, and it means that instead of product, what you should really be aiming for is a platform. And what we do, we take our platform, which contains components, solutions, experience, and we tailor it and apply it to any specific case, on a case-by-case basis. So what are the core areas which group together the components I mentioned? These are things like on-demand data ingestion with validation. This is simply because the platform aims to be a very trusted central source of data for the organization, and trust begins with a very least a technical validation. There shouldn't be any garbage coming into the system. The data should conform to the expected schema, and this is all facing all these different data sources because nobody knows. Data providers wouldn't know what is the enterprise's ideal schema. So there is this bridge to gap which our ingestion components address. And another area of ensuring this data trust is, of course, governance and access control. There should be absolutely a central catalog of data where people can go and discover it based on their permissions, based on team structure and such. This of course offers many advantages around data licensing, ownership, and even onboarding. New person joins organization, they would ideally like to get working with the data on day one. This is a way of enabling it. Of course, modern data solutions are unthinkable without APIs, and this is what we deliver. But API, of course, there is some coding involved if you want to access it. So in addition to that, we offer front ends and solutions such as Excel add-in. A lot of people are familiar with Excel. You install it in, off you go. You can access data very quickly this way. And it's not an abstract concept. Datamax platform. We have delivered it to client production quite successfully. Next slide, please. Okay, so based on stuff outlined on the previous platform, let's talk a bit more about the advantages and typical problems that we have seen. And I think these are problems that every enterprise will be very intimately familiar with today, given that the things like cloud transformations are either well underway or kicking off, and things like these legacy data storage solutions are often not very easy to scale up and out. Things like SQL Server, Oracle, there is a very natural limit. You can take them quite far, but once you start entering the area of terabytes and even further, you start wishing for something else, especially if you don't want to rely on IT to keep a very close, check on how the systems are growing. You want something that just scales with your business automatically. Another typical problem is the rigidity of data schemas. A new data source comes along, or maybe a new shape of data is preferred by a data analyst. Invariably, you have to go to IT. Worst case scenario, you have to talk to developers to implement something. And once you want something implemented, it often takes weeks or months. And what we have is a way of defining custom schemas pretty much on demand. And this is a very powerful model because it effectively decouples your description of data from a data itself. And you can see how it enables things like data governance as well, because you can describe the data in a very minute detail. Other things that we have seen problematic are things like data access limitations. So, quite often people are still integrating with databases directly, and we all know that such tight coupling leads only to problems. And the very best solution offers you APIs with a high element of performance, as well as front end, things like Excel add-in, and potentially things like domain-specific query languages. It's very important to give people a choice that they can pick and choose based on what they want to achieve. Yes, and so once you have these user-defined schemas, you can tap into it and effectively expose it for discovery. You don't need to send emails around anymore asking for what is the best source of data. You simply search for it and you will discover it. And if it says it's a master data owned by Team X, you have full trust in it. Additionally, once you have data in the system and you can access it, a very next logical step is productionizing what you are doing with it. And quite often enterprises, what they want is some way of putting tasks into the system, tasks that work with the data, and in such a way that these logic models can be sandboxed while the work is ongoing, can be shared within a team, can be versioned, and so forth. So this is the overview of the Datamax platform and its advantages. Ralph, are you happy to talk more about components?
Yes, I am. Thank you, Dennis. So thanks for that, Dennis. So we've given you an intro to the business domains, an overview of the problems we're trying to solve, an overview of the Datamax, where it's targeting, the framework is trying to solve those problems. And we're just going to get onto a little bit more detail now about the Datamax components. We mentioned before, it's a framework. We always refer to it as a framework. And as we mentioned, we found that this is a really good way of solving problems, mainly because we see so many times that we go into talking companies about they've bought this off-the-shelf product to solve their problem, and then they spend years customizing the off-the-shelf product to suit their business and to suit their needs. And the product, by the time they finish customizing it, the product's end of life, product needs upgrading, and it has these issues. So here we've got the Datamax components, and the goal is your domain, your business is in the middle, and then the components sit around the outside. With the premise being, you use the components that make sense. Do you want to do ingestion? Are you looking to add APIs to do authorization? Are you looking at some role-based access control in terms of your governance? Excel add-in in terms of getting data to maybe front office analysts or quants in a way that's easy for them. What about, you may have many different databases to connect to. So we have a repository model that allows you to connect to those different databases. The goal being is we're trying to wrap around your business, fit in with the business, as opposed to dictate that the business must follow a certain path to work with the framework. Next slide, please. So here in terms of market data control, when you define a time series, what we're looking at is how do you set a time series up so that as an organization, it's discoverable and it has the right information on it for people to self-serve. In this sense, you're setting up a time series here to describe, I could give an example of a wind farm. And so you'd set up an owner who owns this time series. You would set up some tagging about, okay, well, where is this wind farm located? And what type data does this wind farm record? And you would add this all as a series of meta information. I'll come back to why that's important in a minute. But here we're essentially allowing a user to set up a time series describing what their data looks like. For our wind farm, it could just be simply a integer value and a date representing the amount of power and the date that that wind farm produced that particular amount of power. The key here is you're not restricted as to what that time series setup looks like. We have 2 fields on the screen at the moment, but you can have many more if you choose. We're just setting up a simple example. The key here is when you're setting up your time series, you've already thought about, as a business, how am I going to describe my data so my users understand how to search for it? So if we move on to the next slide, please. So now we're in the searching screen, and this is the key. This is one of the things that we want to prevent: data silos. If it's hard for users to find data, they will duplicate it. You get data silos. They will make their own copy. You get just these common problems happen again because it was hard to find the data in the first place. So by adding the meta tag, just tags to your time series, you allow users with a very simple mechanism to just do a keyword search to find data. Based on my example before, you could type in, I'm interested in wind power in Germany. And then depending on the language you as a business came up with to describe how many tags you would add to each time series, any wind power in Germany time series would then be brought back. Determining what that language is something you would do before setting up your time series. So you would think about, as a business, how do we want to, what data are we going to store? How are we going to tag it so our users can easily search for it? So by searching for it, users can surface it, and then they can also see it. By giving data an owner, we solve one of the problems of governance. It's, oh, I found an issue with this time series. I'm not just going to make my own copy and fix it. Oh, I can go back to the owner and say, there's an issue with this. Can you fix it? Or you can go to the owner and say, I'd like to enhance this. Can we add something more? There's an area we can work together. So we're trying to encourage, cross-business cooperation and keeping the quality of that data. Another example for searching is you may have a meta tag when you're setting up your time series for licensing of data. That's a big thing we talk to people about because the wrong person consuming the wrong license data and that be potentially being distributed outside of an organization can cause many issues in terms of your licensing and fees you may have to pay because your license originally didn't cover that. Can we move on to the next one, please? So we have a very simple visualization tool here. If you're thinking of other tools, Power BI, Tableau, we're not trying to replace them. The key here with the visualization is when the data's come into the system, we're giving users and owners just a really quick way of visualizing it. Does it look okay? Can I see any anomalies? I might want to do a quick search for some things, but apart from that, I'm just wanting to just get a really quick overview of my data in the system when I'm in there. The next one, please. So we've been talking about governance, and this is a Sankey diagram here. And what we're essentially trying to describe with the Sankey diagram is which users use the data for what process. It could be a reporting process. It could be a system that's consuming the data. It just depends. The use cases are all really specific to business, but you could have a front office analyst who's pulling down a certain license data to run an end of day report, as an example. The goal with the Sankey diagram, this view, is to work out, particularly when you're having licensed data, which users are using what licensed data. You will find that sometimes you have many different types of licensed data that might overlap. And if you're wanting to maybe take some license, stop subscribing to some, because these things can be really expensive, the system allows you to figure out, okay, who's using that licensed data, so that I can migrate them off it. And it's inbuilt. And that came back to the very beginning process, how we set up our time series, and we would have added to certain time series, we would have said, you are a licensed data type. And so the Sankey diagram is helping us understand the consumption patterns. Thank you. That's it for me. Any questions there, Ian, or back to you?
Okay, thank you very much, Ralph. Has anyone got any questions at this point? Is it reasonably clear what we're talking about, or is some of this as clear as mud? In which case, do flag it up.
I've got a question,
Yeah.
if you don't mind, Ian. Sort of base data is fine, but quite often in organizations, data is transformed, and then that the transformation in its own right becomes a data set. But what happens is that you kind of really need to know how that transformation was done. You have to know the provenance of the transformation. I'll give you a very simple example in a company I work for. There was, I think, 23 different ways of calculating discounted cash flow. And so wherever you saw DCF, right, you couldn't trust it, because you didn't know how it was calculated. And so is there anything around in Datamax that says, here is, if you want to go back to basics to understand how the transformation was done, this is how it was done. So if you run it, you will get exactly the same transformation.
I could take that one quickly, Ian.
Thanks, Ralph. Please do.
So to answer your question, Harry, what as an owner of a time series, what I would do is I would just use simple tagging to identify to potential consumers transformations, enrichments, business processes, key terms they would need to understand to describe what has happened to this data. You could talk about source systems, enrichment that may have happened, any applications that have happened in terms of merging of data. You would set up a tagging system where you would say, my source is from this system. I used this particular transformation process. I enrich using this process. And the idea would be is you're using your business language, whether that's a team, whether that's a technical term, you would set that up. And that's where the tagging comes in. That's its goal. It's to help you, it's that metadata to help describe the data. Does that answer your question?
Well, maybe, but I'm just wondering whether it actually goes down to the algorithm level to say, not only are we storing the data, but we're actually storing the algorithm that did the transformation.
You could, if it made sense to the data that you're storing, to add an algorithm style tag, maybe someone's interested in how those values were computed,
right?
Because they might need a certain set of data computed with a certain algorithm to be compatible with how they're going to import it into their system.
Yeah. And then the other question, which was a more generic question, is I quite like the idea of these sort of these platforms that try to expose corporate data for common good. I am wondering, you were talking about company culture, whether in some cultures it accelerates silos, because they go, great, I've now got Department X's data, and now I just want to merge a bit of mine. They don't really need to know about this, and you kind of accelerate that silo mentality. Have you seen that at all?
I mean, I can only chip in there and say, I think most of the time people are trying to get things done as fast as they can and easy as they can. So there are probably some nefarious activities that go on, but that's by far the minority. I think the majority is someone's just trying to get their job done. What's the easiest way to do that? And we've seen relationships and organizations where they're trying to build a centralized data store or hub or backbone or whatever you want to call it, and that's taking time to build, and in the meantime someone's got a job to do, so they go off and build their own data store. and nothing more permanent than a temporary solution, as Raj would always say. So you end up with another silo, and it wasn't by design, it's just by necessity or lack of coordination. So I think there's a lot more of that goes on than perhaps nefarious activities.
Yeah, yeah, cool.
Good, thank you, good question. Anyone else, any other sort of points on this, questions, concerns, just some experiences to share?
In regards to the market data control part, do you then have also a part of that tool that scans all the data that you have and highlights what is not tagged correctly?
It's an interesting idea. Ralph, that's definitely one for you.
Yeah, that's a great question. So all the data is available via an API. So you could enforce the tagging when data is entered into the system, so that you set up a set, you know, because it's a framework, we customize the framework to say, right, we have decided that there are 10 properties every time series needs before it can go into the system. And you would predefine those properties with, it could be business process. We've talked about source, license, area, team, whatever governance structures you may have, what makes sense to the business. And then those 10 would be a minimum, but that doesn't stop teams adding more if they want. You want to constrain in one sense to say, this is the minimum we need to go in. And then on the other sense, you want to give some freedom to be like, some teams have actually come up with, you know, the risk team and the front office team are wanting to communicate about something. And so they've come up with their own little tagging structure so that between those two, they add the tag and then it describes data in a certain way. And so you're not getting in the way of them. They can enhance that if they want. So to answer your question, you could set that up so that the framework enforces minimum tags to begin with. On the second part, because it's an API, you can run a scan, a batch job to scan through everything and look for things in a post way. So imagine the system has been running for a few months. You've got some ideas about changing it. The system is built to be interrogated. You would call the API, bring back all the time series meta information, and then just start working out, what am I interested in seeing? Are people actually using the tagging? You could, you know, look for some distinct counts. The information is there. There are APIs for you to mine it out. So it'd be up to your business process as to how you'd want to do that. Think of it as a framework that can supply that information to you.
So starting using the tool, then you would just have a process, or not just, you will have a process going through all the data that you have, and you will add that into the system piece by piece.
Birger, it's nice to see you again, by the way. So there's a number of ways around this, and to build on what Ralph says, that there's an API available to be able to scan all the data sets and see that they conform to valid criteria. And that's something that you could put into place. However, I would probably revisit the requirements slightly. So one of the things you asked for was, is it possible to scan through all the data sets and see if they are validly tagged, or are they correctly tagged? And then at that point, I'd say, then you have an impression of what correct means. So why don't we tell the system that? So this is the mental shift, the cultural shift we talk about with Harry as well. Quality assurance versus quality control. Yes, we can 100% put a scanner in at the end to look at everything was tagged, but let's not do that. Let's do quality assurance. To make sure 100% that as it's entered, every single data set, you cannot progress unless it has every single element. So that's the way it's built. You have this unique set of criteria, but if we have an additional impression of what is correct, you can then fundamentally start adding that in. So it's validation from the beginning. And any data set or any schema that you create has to have those minimal things before you even start. That's one of the tenets we talk about as well. You know, creating things such a way that you just don't let them get disorganized. And by the way, the principle that was mentioned a bit earlier, which was an organization's hierarchy, or the communication structures within an organization reflect the architecture that's created for systems, is called Conway's Law. And it's, yeah, it turns out that there are parallels as well. Yeah.
Thank you. The second thing is, when you have the API there and you have all the data there, can you then also, through the API, limit the access? But if somebody wants, they see the metadata, but they can't access the data. And if they want to access the data, they will get a feedback from the API stating who's the owner?
Great question. 100% yes, and it's very sensible to do so. So there is authentication, there is approval levels, and it ties into an organization's means for role access. In terms of how who the data owners are for a particular data set. It's really important to let people know the things they're not allowed to access. Now, it's quite a complicated statement, but I'll say it again. It's really important for people to understand what they're not allowed to access. Something does exist, but they're not allowed to get that data. They should be able to look at the schema behind it, but understand, okay, well, there's some restricted data here, and because of MiFID reasons, because of X, because of SOX compliance, whatever, there's a number of data sets that they're not allowed to, but they do exist. That's important. So they can request access, for example. So via the API, you can now discover, so you have a service directory, you can discover all the data sets that are there, or two, you can use the application. So use the data set itself, start typing in something like a keyword and go, for example, Reuters or whatever it is that you're looking for, and see all the data sets that conform to that, which you may or may not have access to. But then you can then fundamentally request access to those. And if you're within the right groups, then your access will be opened up. But that's controlled outside of the application in concert with an organization's security infrastructure. And that's really important because that's what you should be looking at rather than keeping it within the system, because then it's part of your joiners, leavers, transfers process. It's on top of everything else and all the good standards that we have.
If I could just add to that very quickly, Raj, one of we plug into Active Directory. So you get the benefit of understanding, because we know who a user is, who's consuming the data, we also can have access to groups as well, in terms of knowing what groups are used as part of, and in terms of data access, which groups can or cannot have access. Thanks.
And it's also tightly integrated with tags, and effectively, imagine you say, this piece of data, it comes from this, let's say, Bloomberg's license, and this group of people is allowed to access everything that is tagged with this tag. So a person will discover that we have actually data available through this license, but you wouldn't be able to get access to that data without requesting it, because eventually it all boils down to that license.
Good. Thank you very much, Dennis. Any other questions on that before I just move on to points to sort of wrap up in the last few minutes? No. Okay, good. So hopefully I can move this forward. Hey, there we go. I'm going to run through just a couple of case studies just to give you some examples of where this applies. So ESG is environmental, social, and governance. It's a bit of a hot topic. If you're in the investment management world, it is the hot topic. You'll see it a lot in renewable energy as well, which is, if you like, a force for good in changing our energy balance. And this challenge, if you're a wealth manager or a fund manager, is trying to assess the ESG ratings for your underlying investments. So if you're investing in Vodafone, for example, versus 3 or one of the other providers, how do you assess what they do on how well they're doing on environmental and social and governance? So you're looking for a lot of different data sources, and Stephen, who's on the call, can talk a bit more about this, but a lot of different data sources which get applied to one's portfolio in order to construct or refine or make changes to it to optimize for ESG components. So you can see it's an entirely data-driven principle. You've got to bring in data from multiple sources, and those are basically reference and ratings data, and they're all valid in their own way, but they measure things differently, or they measure different things, and yet you've only got one Vodafone, so you might apply different data sources to one Vodafone or to one portfolio, and to have a look and understand, what's this telling me about my portfolio? How do I optimize to improve my environmental factors or my social factors or my governance factors? This is an example of an organization called Core Financial, who had a risk product called Bitter Wealth, and they have it's a very good wealth platform, but they needed us to build for them an ESG component, which enables their clients, who are effectively wealth managers, to be able to optimize the portfolio construction for their underlying investors, their punters like you and me. And so the platform we built did that, and you can imagine how much data is required to be brought into the system, to ingest it, to use it as reference and ratings data, and to get a single view, if you like, of the truth around in my example, Vodafone, and its ESG performance from those multiple different data sources. Stephen, anything you want to add to that in terms of the challenge from a data perspective?
I think thank you, Ian. I think the really interesting point is there are a number of emerging data sources. So there are some early ones like MSCI, but there are lots of others, and they each have their own data scale. So some might be simple, like 0 to 100, but many others are either AAA, CCC, and so on. So the challenge here was to also normalize that incoming variance in the way that the external agencies rate companies and their shares and so on, their funds, and then apply it to in a consistent way. And as you can see, 1.5 million client portfolios, each of those portfolios might have had between 50 and 100,000 instruments in them. So it was both a integration of that data, normalization, and then allowing the users to actually work with it and analyze their portfolios, and then also automate that process so that they could also batch it, as that bottom right bullet says. And that really was coming, from a piece of technology developed sort of over 15 years. So we really, applied new patterns of working, and from front to back, in terms of caching as well, and working and making that data highly available.
Thanks, Stephen. And that, think about the three data domains I talked about before. You've got market data, operational data, and then networks and relationships. To some degree, this platform is touching all of those. So you've got market data, which is, in this case, the ESG ratings and reference data, third party. You bring it in, you apply it to operational data, which is, I'm holding Vodafone. I've already got that in my portfolio. It's a trade that was done some time ago. How's it doing on ESG? And finally, it's who's it for? So this portfolio is for me, or it's for Bob, or it's for somebody else. So you're trying to combine all of those factors to optimize the ESG performance in line with the preferences of the portfolio holder, for example. And Stephen said it's never a case of black and white, because different measures yield different results for the same stock, as an example. So it is a challenge in data, sort of ingestion, transformation, enrichment. Looking at another sort of case study, I'll skip over that one then, is MiFID II reporting. This was for Man Investments. I think Birger, you asked a question. I think Harry, you touched on this whole point of data silos and data schema. So the challenge here, MiFID II, this was 2018, MiFID II was on its way. A lot of us knew about that. We didn't necessarily know exactly what the regulations were going to require right up to the last quarter. But what we did know was it was going to be a big job in data ingestion, validation, and enrichment. So this was for Man Investments. That's the world's biggest listed hedge fund group. And they had 4, and now I think it's 5 in total, order management systems. Now, each of those order management systems has its own view of the world, because they represent different businesses. They're actually legacy from a long-short equity business, a quant business, a systematic trading business, and each has a different set of, if you like, functions to support that business, a different view of what a trade looks like. But all of those needed to be ingested into the platform we built, which was called MOL, Man Order Listing Engine, and there's a little bit of the architecture, so that a trade could be represented, if you like, uniformly across the organization. And indeed, a whole transaction across each of those 3 or 4 systems could be represented within the MOL system. And then you can report on it consistently to the regulator every few minutes, every 15 minutes. So we had the concept of golden copy versus golden source, and you had a backwards compatible schema. So the source system, let's say Algo Trading System 1 or Charles Rivers, another one, System 2, we couldn't change their schema, but we had to ingest data from their schema to a common schema internally. And those translation layers, those connectors, is part of the magic to do that. And then, as Raj said, you've got to make sure that you know what data is coming and that it is clean. So forcing validation upstream. So if it isn't conforming to your quality requirements before you ingest it, then don't ingest it. Force that validation back upstream and tell the upstream system what you're expecting, and let that system owner change it immediately, amend the data, correct it. And then when it comes back down and it is correct, then you ingest it. And this is a place where fidelity of data, quality of data is vital. So the upshot of that system was that we saved them $30 million a year, and are still doing so 3 years later, just from a system that well designed, well built, and reduces human input to an absolute minimum. The machine does the work. So that's a 30 million saving year on year on year, but we also improve their data quality. These are their measures, not ours, from 65% to 99.9%. And from that, you can do analytics. You can measure trade, if you like, alpha, as in the performance of your trade ideas, from the idea right the way through to the post-trade execution. No one's ever done that before. You can do trade surveillance. You can do front-running surveillance. You can offset long and short trades within your own book. None of these things could they do. And all of those are benefits over and above the mere 30 million we save them. So it's a very good example of ticking the regulatory compliance box, but also being smart about the data engineering to give you a platform which has many, many uses across the organization. And I'll touch on one last one, which is a completely different use case. This is in the insurance linked security sector. So combine insurance, or in this case, reinsurance, with investment management, and you end up with ILS, insurance linked securities. And it's a very interesting space because you're combining a reinsurance product, which is about when a Florida windstorm hits or a tsunami hits, who are you going to pay out for? Whose underlying insurance are you going to support when 1 million homes get hit by a big windstorm? And that has a lot of characteristics like any insurance policy. It only pays out certain amounts of money under certain conditions for certain periods. But you're going to turn that into an instrument that you and I can invest in. And that's what ILS does. And our platform that we built for them manages the cash component, the portfolio management, the profit and loss. It manages all of the trade-related activities and compliance activities. And the only way you can do that is to create a single version of the truth. So if you make a change to something in your portfolio, whether it's a planned change or an actual change, you can have a different state in that workflow. Then what you want to do is represent that change. I've bought or sold something, or I plan to buy or sell something, and represent the effect of that change on cash, on profit and loss. And in the case of this world, potentially also insurance losses. And insurance losses can be very big and can last for many years. So you've got to provision a loss, and you might spread that across multiple portfolios. And you've got to see the effect of all of those things in near real time. So that's what this Chrysalis platform we built did. And again, many, many, many advantages. It allowed their business, in simple terms, to grow from 1.5 billion of AUM to 6 billion of assets under management. And they added 1 extra person, which is pretty impressive. So they've more than quadrupled their profitability and added 1 extra person because they're not running around chasing the next spreadsheet. Their nearest competitor, who did the same growth from AUM of about 1.5 billion to 6 billion, has 3 times the number of staff and consequently 1/3 the profitability. So that's a very good use case of smart design of systems and data. So final points here. You need to acknowledge and organize your data landscape. You know, there's not a one-size-fits-all approach, and some of your questions clearly reflect that. But build a kind of robust digital nervous system across the organization is the objective, and put the power in the hands of the users. You know, you can have data custodians, no question, but you can't have people managing and curating all aspects of your data. Let's use technology to do that for you. So your question, I think it might have been Harry, that Ralph answered is, you know, you might have a certain use and a view on a piece of data. Let's take a name. My name's Ian Murrin. Someone needs that bit of data, and someone else needs to know where I live, and then someone else needs to know where I live and how, you know, what my credit card transactions look like. But let's tie it back to the single person. Let's not have a duplicate that covers the transactions, a duplicate that covers the address. So you're trying to have a single view of the truth, but present the data, a view on that data as appropriate for the business domains, which is what we touched on earlier on. And facilitate this fluid collaboration across the enterprise and within those functions through metadata. So the description, making it easy, discoverable, and easy to enrich is vital. Otherwise, it's just data. It's meaningless. It's not intelligence to anyone without it. And if you can control that, then you can control costs. You can avoid duplication, and you can overlay good, efficient workflows and increasing automation. So that data maturity that Raj talked about, you can't do that if you've got everything in spreadsheets. Never going to happen. But if you have a single view of the truth, where the data domains are accurately represented for the different bits of the business, but it's a single source of data, then you can start to automate things, and you can put machines on it to learn from that. The other one is data security, you know, minor, but major, really major. So authentication and authorization, both from a GDPR and in a reputational risk perspective, but also from a licensing perspective that Ralph also touched on. And an open extensible architecture. So we talked to you through some of the benefits of our DataMax platform. It is a very open, extensible architecture. It is not a thing. It's an approach and a set of components used to build the platform that meets the needs of our clients. And we've never seen an environment where a thing is going to work in a complex enterprise environment, because there is so much legacy, so much precondition you've got to work with. And finally, these building models, as in we talk about quant models, all of that runs off data. So you've got to get your data right for the quant teams to be in any way productive. And most aren't, sadly, because of that. Key takeaways: try increasing yourself, rate of progress up this data maturity continuum we talked about. Easy to say, very hard to do. Everything we've talked about is really an aim of trying to reduce the roadblocks to doing that, or accelerate the rate of doing that. And this vital first step towards creating a data strategy is thinking about things from a single view of the truth. So a name, enrich it with an address, enrich it with credit card data, enrich it with whatever you want to, and describe the enrichment process so that it can be understood by somebody. That transformation process that Harry touched on earlier on, understand it so that you don't have to duplicate it in order to use it. You've got a single view of the truth from that single piece of data, but it has many applications. Take stock of your data assets, inventories, and map it. Plan for legacy data sources, because they are going to be there, but focus on it, if you like, a data hub, data backbone. And finally, prepare for scale, for the volume of data, because to some degree you will always be a victim of your own success. If you've got a problem of scale, you've probably been quite successful. So that's going to continue as people use more data, generate more data, apply more data. Bear in mind the scale of that is going to be probably beyond what you expected in the beginning. But that is it from us, I think, unless there are any other questions. I've got a few more case studies, but probably not much time to run through them. But any on a wrap-up questions with anybody? No. Okay, well, thank you very, very much for joining us. I hope it's been mildly informative, even mildly amusing. But if you have any questions at all, just want to bounce some ideas, either send them to myself, Ian Murrin, or to Raj Jeth at digitair.com.